Polystyrene can be made from benzene in the series of steps shown. In step 1, benzene reacts with the acylium ion CH3CO+. Name and outline the mechanism for step 1. So this is going to be electrophilic substitution. For 1 mark, and if I go here and cut it there, that's going to be my electrophile. So I'm not asked to draw a reaction or write a reaction for the production of the electrophile, so I'm going to go straight into the mechanism. So there's benzene, and then I've got CH3, so a curly arrow from or just inside the ring there, so 1 mark for that. And then 1 mark for the correctly drawn intermediate. So it doesn't matter where I put it, so I'm deciding to put it here. And remember that delocalization cannot occur around there, but it can occur around all of the other carbons here with a positive charge in. So 1 mark for the correctly drawn intermediate, and then 1 mark for the curly arrow from the middle of the carbon-hydrogen bond back in, and that makes that product there at the end of step 1. Okay, state and name the mechanism for reaction 2. Identify the inorganic reagent needed. So let's go back to step 2. Let's just have a quick look. So this is a ketone. So I've got an R group over here and here. And what I'm making is, you can see that I'm making an alcohol there. So I'm going from a ketone to an alcohol. So that's going to be the reduction stuff. So the reduction mechanism is nucleophilic addition. The reagent is NaBH4, and the name of the organic product, so let's go back and have a look. So the name of the organic product here is, so remember benzene becomes phenyl, and I've got an alcohol, so with 2 carbons in here. This is going to be carbon number 1, and that's going to be carbon number 2. So it is 1-phenyl ethane 1-ol or ethan 1-ol. Okay, so let's jot that down there. So 1-phenyl ethan 1-ol. Although it does say in the mark scheme that it would just allow ethanol here. So if you've written 1-phenyl ethanol, that would be okay. Part D, the organic product of step 2 is reacted with sulfuric acid. In step 3, outline the mechanism for step 3. Let's go back and have a look at step 3. So again, it's a case of just looking at what is changing on here. So in this one, I'm going from an alcohol to an alkene. So this is going to be the elimination or dehydration reaction. So the mechanism then for this one, so let's put the benzene ring over here. That's the benzene ring isn't really important here. So I've got CH, OH, and then CH3 over here. Now the sulfuric acid is my source of hydrogen ion, so there's my hydrogen ion here. So 1 mark for that curly arrow there. So again, benzene ring is often put into these things to confuse you. So O, positive charge on there, and then hydrogen. I need to display the neighbouring methyl group because we need a hydrogen on there. And then the final step here is from there to there, and then any one of the 3 hydrogens on the adjacent methyl from there to there. So 1 mark for the intermediate, and 1 mark for the 2 curly arrows that have been drawn. And then part D, draw the repeat unit of polystyrene. So let's just go back up to here. So, okay, so polystyrene is going to be the polymerization of styrene, which is this. And we've got a carbon-carbon double bond here, so I'm going to get rid of that double bond there and extend it out here and here. Okay, so that's my working out there. So let's just kind of draw what we've got there. So I've got a carbon-carbon double bond here. I've got a benzene ring on one of them. And then to polymerize it, if you remember, get rid of one of the double bonds here and out from there.